So student, today we will study the nuclear force. So what do we mean by the nuclear force? We know the average separation between two nucleons is 10 to the power minus 15 meter. Now at this separation, positively charged proton feel some electrostatic repulsion force for which suppose there is two protons and it has positive charge, and for this there should be an electrostatic repulsion for which it cannot hold the nucleons together. So to overcome this, there should be some attractive force, strong attractive force which binds the protons and neutrons inside a nucleus, and this is called your nuclear force. It is very strong in nature. It is a short range force, and also if we consider the nuclear force between proton and proton, neutron and neutron, and between two neutron and proton, these are same. So next we will study mass energy equivalence. So what do you mean the mass energy equivalence? So Einstein showed from his theory of special relativity that we can treat mass as a form of energy. So one can convert mass and energy into various other forms of energy. Now he showed a relationship between energy and mass, where c is the speed of light in vacuum. This equation shows that even when a particle is at rest, suppose particle is at rest, means it has zero kinetic energy, it will still possesses enormous amount of energy because of its what? Because of its mass. Because of its amount of energy because of its mass. So this equation actually shows the equivalence between mass and energy. So next we will study what do you mean by the mass defect. So if I consider 3 protons and 3 neutrons together, they form a nucleus. So it is seen that the mass of this nucleus is always less than the sum of the masses of the nucleons. Sum of the masses of the is always less than the masses of the sum of the masses of their constituent nucleons. So if I consider one nucleus, that is X, and its atomic number is Z and mass number is A. So it has Z protons and A minus Z neutrons. So we can write its mass defect by denote by delta M equal to Z MP. Z is what? Z is atomic number, MP is the mass of the proton, plus A minus Z, that is the number of neutrons, into mass of the neutrons, minus M, the mass of the nucleus. This is the expression for mass defect.